All right, let's just jump right into it. Welcome back, everyone, to Module 10. We hear about AI literally everywhere right now, right? It's on the news, it's in our feeds, it's completely inescapable. But beneath all those flashy headlines and, honestly, the soaring hype, there is this immense, physical, humming reality that almost nobody talks about. So, in this explainer, we're popping the hood. We are looking straight at the actual infrastructure, both physical and virtual, that powers modern AI. We're moving way past the theory today, and we're getting right down to the nuts and bolts that make all of this magic actually possible.
Now, we've spent our previous modules really marveling at the incredible capabilities of generative AI and these autonomous agents. We know they can write code, they can analyze massive, dense data sets, and they can completely manage complex workflows all on their own. But for our non-technical learners out there, I really want to pose a critical question today, one that bridges all our past conversations to today's focus on the back end, and that is, where do these AI agents actually live and work? Because, people often think AI is just this chat box floating in the ether, right? Like some magical cloud that just somehow inherently knows things. But the reality? They absolutely don't just float in a magical cloud. They require massive, highly orchestrated physical and virtual resources to function at all.
So, I want to introduce you to the concept of the AI factory. To run agentic AI successfully, a business needs an incredibly immense, coordinated data layer to execute tasks across an entire enterprise. Think about it like this. Moving from a little isolated proof of concept, say a single simple chatbot running locally on a developer's laptop, to a massive fleet of production agents is a huge, huge leap. It's literally like moving from a single craftsman tinkering away in his residential garage to a sprawling, fully automated automotive plant. A factory that produces thousands of complex, autonomous decisions every single minute needs serious, heavy-duty power. It needs rigid structure and absolutely flawless management.
So here is our roadmap for today's explainer. Welcome to the AI factory, followed by blueprints, infrastructure as code. Then Kubernetes, the floor manager, sharing the heavy machinery, securing the agentic enterprise, and finally, the runway for scale.
Moving right along to Section 2. Blueprints, infrastructure as code.
Okay, imagine the sheer chaos of trying to manually build a massive, sprawling factory, brick by brick, every single time you needed a new assembly line. It would be an absolute nightmare, right? Well, what if you had perfect, automated blueprints instead? That is infrastructure as code, or IAC. It simply means writing lines of code that instantly and automatically provision your computer resources perfectly every single time. Instead of some poor human clicking endlessly through menus to set up servers, we use tools like Terraform to declare exactly what the infrastructure should look like, and tools like Ansible to configure the software inside it. It's basically like handing a flawless digital blueprint to an army of lightning-fast robot builders who can literally assemble a skyscraper in seconds.
Let's contrast that manual, brick-by-brick legacy approach with this modern automated reality. The old way relies on humans manually configuring servers. That takes weeks, and it carries a massive risk of human error. It introduces this nasty little thing called configuration drift. Imagine giving two different human builders the exact same blueprint, but over the course of a year, one decides to swap out the standard screws, and the other decides to just slightly tweak the electrical wiring. Eventually, those two buildings aren't identical anymore, and things start breaking completely unpredictably. The new way, utilizing GitOps and IAC, prevents this entirely. It provisions your multi-cloud infrastructure automatically. It takes hours instead of weeks, and it guarantees perfect replication every single time. No swapped screws, no rogue wiring, just perfection.
And the crucial business impact here? Honestly, it cannot be overstated. Recent research looking into telecom cloud environments showed that adopting a hybrid infrastructure as code strategy reduced deployment times from 168 hours, guys, that is a full week of nonstop around-the-clock work, down to just 2 hours. 2 hours. That is a total game changer for a business. It means the end of a very relatable corporate pain point. When an enterprise needs to spin up a brand new AI environment, their teams aren't waiting in line on a month-long IT ticket. They submit the code, and the entire factory floor is fully operational and ready to go before they even leave for lunch.
All right, Section 3, Kubernetes, the floor manager.
So now that our factory is built instantly using code, we need a really robust system to oversee all our autonomous AI workers out there on the floor. Enter Kubernetes. Now, if you've spent any time around modern software, you've definitely heard this buzzword. But to keep it super simple, think of Kubernetes as the ultimate hyper-efficient automated floor manager. It's a programmable control plane. Imagine a manager who watches the assembly line with perfect precision. If your AI application suddenly gets absolutely swamped with user requests, this manager instantly clones your AI workers to handle the load so nothing gets backed up. And if an AI worker suddenly crashes, the manager instantly sweeps it away and replaces it with a fresh one before anyone even notices. It completely abstracts all that underlying complexity so your developers can just focus on building the AI itself.
Think about the journey of the data dynamically, kind of like a package moving through a high-tech shipping facility. When a user or system sends a request, say asking an AI to summarize a massive legal document, that traffic enters the edge zone. It hits an ingress gateway, passes through a routing API layer, and is sent directly down to the model-serving pods. And those pods, those are the actual working AI agents sitting right on top of the physical computing nodes. The Kubernetes manager acts like the world's greatest air traffic controller here, ensuring that all this rapid-fire traffic flows flawlessly to the exact right destination without overwhelming any single worker on the floor. And the thing is, Kubernetes doesn't just manage the final product answering questions. It actually manages the entire assembly line leading up to it. We call this the end-to-end MLOps lifecycle. MLOps just stands for machine learning operations. Think of it in 4 really simple steps. First, data preparation. That is sorting and cleaning the raw materials. Second, model training. This is the phase where we are actively teaching the worker how to actually do its job. Third, the model registry. This is where we store the finished AI, essentially giving it a uniform and a name tag so we can easily find it later. And finally, online inference, which simply means putting that trained worker live on the floor to start answering user questions. By keeping all 4 of these steps on one single Kubernetes platform, the entire lifecycle becomes totally unified and seamless.
Moving to Section 4, sharing the heavy machinery.
Here's the catch. All of this brilliant software logic is completely useless without raw physical computing power. And in the world of AI, that means graphics processing units, or GPUs. GPUs are the massive, highly expensive superbrains of our factory. But here is the major problem. Some AI tasks are actually quite small. Giving a tiny task a whole dedicated GPU is exactly like renting a massive commercial crane just to lift a single brick. It is wildly, ridiculously wasteful. So to fix this, we use a technique called GPU partitioning. Specifically things like multi-instance GPU, or MIG, and time slicing. This essentially carves up one massive physical chip into multiple smaller virtual chips. This way, several different AI workers can share the exact same resources incredibly efficiently without stepping on each other's toes. In other words, we use the crane to lift a whole pallet, not a single brick.
Because at the end of the day, the absolute ideal cost target for an idle GPU is zero. $0 wasted. Cloud GPUs are astonishingly expensive, folks. We are talking about computer chips that can cost as much to run as leasing a luxury car every single month. So if your AI application isn't doing any work at 3 a.m. because your users are all asleep, you absolutely should not be paying for maximum computing capacity.
And that brings us to elasticity, which is absolutely critical for enterprise survival. There's all this behind-the-scenes tech with dense acronyms like HPA, which is the horizontal pod autoscaler, and KEDA, which scales things based on event queues. But honestly, you don't need to memorize the acronyms. You just need to understand the Super Bowl analogy. These technologies allow your factory to literally breathe. They ensure your AI capacity instantly breathes in and scales up to massive proportions if your app unexpectedly gets featured in a Super Bowl ad. And critically, they ensure your factory breathes out and scales all the way down to near zero at 3 a.m. when traffic stops. It keeps your business online during massive spikes, and it strictly prevents bankruptcy from idle server costs when it's quiet. A total win-win.
Section 5 now, securing the agentic enterprise.
Okay, so as we give AI agents more and more autonomy to take actual actions across our business, we desperately need safety guardrails to keep them from accidentally or maliciously breaking the factory. The sources outline a set of critical governance invariants designed specifically to minimize the blast radius if an AI agent ever goes off script. Let's break these down simply. First up, role-based access control, or RBAC. Think of this as a super strict VIP keycard system. The AI only gets access to the exact rooms it absolutely needs for its specific job. Next, default deny network policies. This means all digital doors are locked from the outside by default. Systems literally can't talk to each other unless they are explicitly introduced. Third, least privilege limits. This ensures an AI only gets a tiny allowance of resources, not a blank check, so it can't accidentally bankrupt the system if it gets stuck in a loop. And finally, admission webhooks. These act as active security checkpoints, automatically auditing and scanning any new process before it's allowed anywhere near the factory floor.
And finally, Section 6, the runway for scale.
So, what is the ultimate business destination of all this complex infrastructure we just built? I absolutely love this quote from the Cognizant paper because it just perfectly captures the why of it all.
A solid, governed platform layer elevates AI from just being a simple chatbot that answers trivia questions into an active agent that does complex, multi-step enterprise work. Because the infrastructure is secure, scalable, and automated, these agents don't have to wait around on human handoffs. They can interpret intent, and crucially, they can reason over enterprise context. Now, for a business owner, reasoning over enterprise context means the AI actually understands the specific rules, the HR policies, and the live inventory of your exact company, not just general facts scraped from the internet. It can then actually execute coordinated actions directly inside your live systems.
So let's bring it all together. Combining the flawless perfection of our digital blueprints with infrastructure as code, the brilliant floor management and routing of Kubernetes, and the raw, optimized power of partitioned GPUs creates something truly incredible. It provides a single pane of glass for an entire organization. It essentially transforms what used to be a fragile, isolated science experiment running on one guy's laptop into a glowing, enterprise-grade runway, fully equipped and ready to safely launch vast fleets of autonomous AI agents.
So, I will leave you with this final thought for today's explainer, and I want you to really consider this. As we move into an era where we hand over more and more true autonomy to AI to run our daily systems, is your business currently running on a fragile, manually operated workshop that will completely collapse under sudden pressure, or have you done the hard work to lay the foundation for a truly scalable, automated AI factory? Because making that transition, that is the defining challenge for businesses right now. Thank you so much for exploring Module 10 with me today. Keep learning, keep building, and I will absolutely catch you in the next explainer.